Well, hi there, everyone. My name's Henk, and I'm here to talk about a project I did on education in Rust. And this talk is called Oxidizing Education, and it's about enabling teachers to teach Rust. And first of all, I would like to thank the GOSIM organization for the hospitality and the opportunity to speak here. It's been a great experience so far, and I think it will be for the rest of the conference, so thank you very much. And also, I have to say I didn't do this work alone. I work with a couple of colleagues of mine, and one of them is Volkert. He is one of the speakers on the conference, should be walking around somewhere in this venue. Right, so, but who am I? Well, my name's Henk, and I'm an embedded software engineer and a Rust trainer at Tweede Golf, which is a Netherlands-based software engineering agency. And I've been doing Rust for about 5 years now, and currently my day job is working on IoT devices using Rust. So these devices, they don't have an operating system, just bare metal. The idea is that these things are able to connect with cellular and work for 10 years on free penlight batteries. So yeah, Rust comes in pretty handy for the performance. Also, I host in-company Rust trainings at external companies. Which is something I really love to do, make people enthusiastic about this technology. And furthermore, I am, well, one of the maintainers of Rust 101. So here's my GitHub handle. It's a bit about, yeah, I don't think you can see it, but anyway. I'll share it at the end. So first off, oxidizing education. I think most of you know this, but in the Rust community, we use the word oxidizing to slowly introduce Rust into a project. And I think this is exactly the way we should go about education. Well, take it slowly. And this is what I'm here to speak about. But first, I would like to know something about you. And I'm going to ask some questions, and you're invited to raise your hands if you fell into a certain category. So first off, who here is interested in learning Rust? Well, I am. Right, so that's a lot. Great to see. And so which of you has been learning Rust by themselves? So they did some self-education on Rust? Also a lot. That's awesome. And then who here had actual education at a university or some other institution in Rust? 2, 3 people? I mean, that's 4, that's more than I expected. So still, that's great. And who has been teaching Rust to other people, apart from Bart and yeah. Yeah, still some. So this is a good audience. Because this talk is for people who want to teach Rust for others and for people who would like to learn Rust at their educational institution. So if you're a university student, well, hopefully you may help out your university using the stuff we have been creating to have them teach you Rust. And also, if you are good at Rust and you would like to improve the learning experience for other people, then yeah, hang on. So these are the questions. Right. So first, let me once again introduce Rust, but the things that I feel are most important about it. Because first of all, So Rust is really a broad language. It can be used in a wide variety of fields. So it goes from performance critical systems to operating systems and adjacent code You can do web development, you can do front-end web development, you can do GUIs, you can do back-end development, you can write CLI applications, you can also do embedded with or without operating systems. And so this shows that Rust is really, really general purpose, really versatile. And one important thing the Rust official website has to say on the front page is they call Rust a language that empowers everyone to build reliable and efficient software. And I think this is one of the strongest points of Rust. So this allows people to fearlessly work on cool problems. People don't have to be afraid that they won't be able to make production code because they have good guardrails, and I think that's really awesome, and Rust helps you out so much. And also there's this, well, pretty famous pie chart, I think. This is from a survey Google did on their comprehensive Rust course. And what it shows is the time until participants were confident writing Rust. And what I think is really striking is that even though a lot of people say that Rust is hard to get started with, I'm not sure that's true. I've heard counter arguments. But what we can see here is that a lot of people, like 2/3, say they are confident writing Rust in 2 months, which I think is really impressive. And this is one of the biggest strengths of Rust, I think. So even though it may feel hard at the beginning, it is not hard to get really good at it. And this is a stark contrast with other systems programming languages. And there's also this metric, Stack Overflow's most loved language for 7 years in a row. It's onto its 8th year. And I think, yeah, it's great marketing. And so GitHub has written a blog about why this might be. And they find that people say the speed and the safety and the performance of Rust is one of the biggest things that they think is positive about it. And also a mindset that prioritizes innovation without compromising stability and security. So this is something Rust calls zero-cost abstractions. We want really cool, high-level ergonomic abstractions, but we don't want to pay for them, especially if we are not using it. And if we are using it, we really want to strive for the best implementation there is possible. And people often mention the tooling, like Cargo being awesome, and well, there's the type system, very expressive. The error messages, I think they're great. When I'm doing in company workshops, I actually have to tell people to have a look at the error messages because they are actually helpful, which is surprising to people. And of course, there's a great community. It's just such a helpful community, and has been for years now, and even still now Rust is growing, the vibe is still really positive, and I love that about Rust. But also, as Josh mentioned yesterday morning, Stack Overflow's verdict is a bit biased, and one of the reasons is that Stack Overflow counts the people that have used Rust and want to use it again. And as Josh said, not a lot of people are current Rust users, right? But also, I think that most current users, they chose to use Rust. They never got forced to use Rust by their employer or by their university. And so, in a sense, in a way, I would like to have us not be the most loved language anymore, because I want, well, more of a balanced view on this. So here's what I think is going on with Rust. It has a bit of a bootstrap problem, chicken and egg, what came first. So it goes like this. Well, of course, Rust is great and all, but there aren't a lot of job openings. And so yesterday I spoke to someone who told me that in Shanghai there were like only 10 Rust job openings currently in this huge city. So I mean, it's a thing. And I think this is because companies are hesitant to adopt it, obviously, because there aren't many experienced developers. So, and developers think, why would I learn Rust? There aren't any jobs in it. And companies think, why would you use Rust? Because there aren't any developers. So we need to get out of this cycle. We need to break this loop. So how would we do this? Well, this is done by oxidizing education. Is one of the ways, I must add. And this is really a long game, so I think it's good to get started as soon as possible, but I don't think it will have a big effect anytime soon. Even still, yeah, everything helps. So what does the education currently look like? Well, I think everybody knows that C and C++ are the dominant languages, the systems languages in education. So if you want to do pointer stuff, well, you're going to do C or C++. And C may appear small and beginner-friendly, but there's loads of caveats and traps, so it really isn't. So this is one of the languages that may seem hard, may seem easy to get started with, but is really, really hard to get really good at. And C++ is another example of this. It is a huge language, but still, you can teach object-oriented programming with it, and it is really widely used. So I think these are the reasons. And well, Rust in universities is pretty rare. So I had a bit of a look at the universities in the Netherlands. There are about 22 universities there. And so one of them is actually flirting with Rust a bit. And I'm proud to say that another one is actually teaching it. But I think this is, well, a pretty high relative number. So I'm not sure. I think in China, it's pretty unique. I think in the United States, it's pretty unique. I think in Europe, yeah, it's pretty unique. I haven't heard much about Rust courses, sadly. So what can we do about this? So one approach is to make Rust as approachable as possible for new developers. So this is also something that Josh talked about yesterday. And one of the cool things is you can, well, improve the compiler errors even more to help people, well, really understand what is going wrong. And I think the compiler is already great at this, but there's like these async concepts and lifetimes, and sometimes it really gets hairy and syntaxy, and it's really good if we can improve this. So there's work going on this. Also, there's the RustVis project, which I think is pretty cool, which is about visualizing references, lifetimes, ownership of code. And yeah, well, Bart's organization, Rust Edu, does great work supporting this. Thank you very much. And another thing that we can do is, well, enable educational institutes to teach Rust. And, well, we can even help everybody teach Rust. So this is where Rust 101 comes in. This is the pitch. So yeah, Rust 101 is about enabling teachers to teach Rust. And so what is Rust 101? Well, Rust 101 is a modular, reusable university course on Rust, and it is designed for in-person teaching. So there's there's the modularity to it. You can pick and mix the topics you want to cover. You can edit the content at will. I mean, like, no teacher is going to copy and paste the slide content right into their own course, right? So it needs to be easy to edit it. And also, Rust 101 wants to make it easy to add or contribute your own material to the project. And furthermore, it's reusable. It should act as a resource to base courses on. And it should be possible to compose tracks for different audiences and different objectives. So one thing you might ask is, don't we already have lots of material? Just this morning we heard we do. There's loads. Some of these are listed here. So there's the famous course Comprehensive Rust by Google, which I think is great. Then there's the Rust programming language book, which is also great, and it's free. I mean, that's like the best way to get people to learn a new language is by making stuff this high quality, freely available. And then there's John Jangset's YouTube channel, Crust of Rust. I wouldn't say it's beginner friendly, but it's really, really thorough, and it's really awesome. And there's many, 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 many more. However, I think that, well, each of them has one of these things missing. So either they're not meant for in-person teaching, or they're not modular, or not easy to adapt or they're not so easy to contribute to. And so for Rust 101, I want to do all these things. So another thing you might ask is, well, can't teachers do this themselves? Why are you doing this as a software engineer? Good question. Because, yeah, it's their job. They are good at it. They are much better at it than I am. But I think there's no harm in helping out, right? So I think as an industry and as a community, we can give them just that little push forward. Enabling them might help. And then, do people even want this? I think yes. So we've got 2.4K stars on GitHub. I'm sad to say that it isn't the most popular GitHub project of TweetDeGolf anymore. We got overtaken by sudo implementation. Yeah, but I think, yeah, we're still really close. Also, the Rust Foundation thinks so. I've got a grant from them to work on this. Thank you very much, Rust Foundation. And also, just yesterday, Rust Education gave green light on another piece of funding, which is just awesome. Thank you, Bart. Yeah, so I think we can conclude that people want this, and our marketing team has been noticing this as well. We have been doing a lot of sharing on social media, and what they see is that Rust 101 content gets by far the most engagement on social media, so it seems like people want this. So how would you go about setting up something like this? So this is the rough plan we had, and that, well, formed along the way, I should admit. So what we did first is we went ahead and set up and run a tailor-made Rust course. And then, given the content that we created for that course, we adapted it and modularized it. And then the idea is to set the whole thing up for external contribution and use. And then, yeah, hopefully profit sometime. So let me tell you about the first run of Rust 101, which was this spring at the Slovak University of Technology in Bratislava, Slovakia. So it was a optional course. There were about 20 computer science students. And the idea was that they would also have some future teachers take this course, so they can then, well, organize this course themselves next year, which is great. And so what we knew about the audience was, well, pretty much this. They had intermediate C++ skill. So what does that mean? Well, I think we can assume that they know something about manual memory management. I think they know what pointers are, right? Also, they are used to doing object-oriented programming in some way. So we have to unlearn some things. And I wanted to note that even though this may seem like this course is well made for C++ developers, well, currently the content is, but I don't think it should be in the end. I think you don't really need intermediate C++ skill to learn Rust. So that would be a great improvement in the end, but I'll come to that. So here's the schedule. We had a 12-week course. And actually the first week was in person. Me and Volkert went there by train. And well, the train we were in was really, really slow. And it was horrible. Volkert liked it though, I don't know why. Yeah, but it was great. And the rest of it was done remotely. And we had divided the content up in 7 modules. So each of them consisted of one 90-minute lecture. And then we had one 90-minute tutorial with exercises. That was the idea. So each of these modules has the same agenda, so to speak. And then at the end, we did one final project as sort of an assessment with a weekly check-in. And during the weekly check-in weeks, we also did 2 live coding sessions. I did one on embedded development, and Volker did one on the compiler he's creating in Rust. And we had some goals. So first of all, we wanted to have people dive deeply into fundamental stuff. So it really helps in the end if your base is solid. And this is something that we really wanted to make sure we did. And also, we wanted people to have practical hands-on experience. So we didn't just want them to be able to make an exam on Rust. We wanted to be able to use Rust to write actual applications and use the ecosystem around that. Also, it's good to have students understand the problems that Rust aims to solve. For instance, if you have never had anything to do with manual memory management, then why would I need to do all these hard borrow checking stuff? And yeah, we need to make sure people understand why they are doing this. It helps motivate them. And also give them a bit of an ability to judge whether Rust fits requirements of some project. Answer is always yes, I think, but yeah, I'm opinionated. And so what's also important is to understand why Rust features are the way they are. So how did they come to be? A bit of background as well was the idea. And there was the structure. So first we had the 7 modules, and module A, which was an introduction to Rust itself, took 3 weeks. And the idea of this module was to have a foundation for each of the other modules to build upon. So you could the idea was you could, if you wanted, teach module A and then go teach module D and then other modules in another order if you wanted. So A was designed as something that you need to know to learn each of the other topics. Then there was B, called application programming. So this tells you a bit about the ecosystem and pulling in external crates and testing, benchmarking, all that stuff. So making your application like production ready and the tooling you can use for that. Then we had a module on concurrency and, well, especially parallelism, using Rayon, and people were writing their own mutexes, which was pretty cool. There was one on trait objects and Rust design patterns. So this is where we had to unlearn the object-oriented programming, which was pretty cool to do, I think. And then we had a module on async Rust for web. There was a module on using unsafe Rust safely. We did finally one on foreign function interfacing. And then we were done with the lectures and started with the final project. So, how did it go? And what did we learn? So, spoiler, I think it was awesome. So here's the first module, module A. Here's me here in the blue sweater. I tend to put my face on my slides. And here's Volkert, and this was, well, in Bratislava. These are our students. And, well, we covered some topics, such as basic syntax, move semantics, ownership, borrowing, all that stuff. We did enums, pattern matching, error handling. We did generics. We learned about some common traits from the standard library. No, this wasn't, not all these topics were taught in the first week. Not all of them were in Bratislava. This was spread over the 3 weeks. So I think having done that, we can list some things that turned out to be, well, hard. And one of the things about teaching fundamentals of Rust is that it's really hard to go easy on the concepts. I thought it was quite hard to introduce topics and find out which order they should be in, because there's also chicken and egg problems going on there. There's loads of syntax. I'm not going to tell anyone that Rust syntax is beautiful. And, well, students agree. So there's some various circular dependencies as well, like the references. They kind of have to do with lifetime annotations. And then there's the static lifetime. How does that work? Always come across those things. Yeah, traits and generics is kind of new to some people, and there's a load of syntax involved with that. And one of the things was, how do we like teach slices and string slices? What's the difference between arrays and what's the difference between normal strings, right? So it was quite hard to come up with a good explanation for those things. Also, we found that most of the time the reason behind something being complex in Rust is, well, an advanced topic. And so you've got another circular dependency going on. And also something that I think we should have put more effort into was make clear the context, which was one of the goals. But it turned out that later on in the course, we had to tell students that Rust is actually a compiled language. So we didn't do too well there. Yeah. So what did we learn? We should next time focus on explicitness of complexity and what that solves. So why is the complexity so explicit in Rust? What is it good for? And also, yeah, as I said, more focus on the context in which Rust operates, it being multi-purpose, it being a systems language, it being optimized, and also have more of a look at existing content, because people have done this before, and we were too, well, we should have done a bit more on that, I think. But also, I think that it turned out to be rather complete in the end. And also, again, the Rust compiler warnings and errors, they are great for teaching. So once you've got your students reading them, actually, well, it really helps them understand what they're doing. Here's another module we did, async for web. And the goal of this module was to give students the ability to reason about futures and executors and, well, use async in web as well. And so they should be able to know, like, why isn't my future compiling? And a non-goal was writing the fundamental features that interface with operating systems and stuff. A non-goal was writing executors, but it was a goal to understand broadly how they work. And so some of the topics we covered, first off, we did an overview of async in Rust and how it's different in than in other languages. You have to bring your own executor. Futures are inert. And then we went into the future trade from the ground up. So we started with, calling all the time in a big loop, and went on to wakers and it being efficient. And then we finished at the actual future trade, which I think was a good way to teach it. Then we went on to the async and await keywords and how they transform the code. And this is the point where we saw that async Rust, it seems pretty magical, but it really, really isn't. And I think this was one of the greatest things about this module. Then we went on about how do you run the future with Tokyo, and then we had a small part on Rust for web. So one thing that's hard about teaching async Rust, it's really, really in a rabbit hole, and it involves many, many concepts. And if you know Rust, you know that it's hard to get started with async sometimes. So some of these concepts here: future, waker, pin. Does anybody know how pin works exactly? I tend to forget all the time. I mean, so one day I read about it and then I think, yeah, I think I understand this, and the next day it's all gone. Yeah, we went on about async await. It's another topic. Well, concurrency being mixed with parallel, you have to introduce. Why bring your own executor? So there's a lot to explain before people can even get started. And also, we wanted to apply async using web development with Axum. But web development itself is a huge topic, so then cramming it into another huge topic wasn't such a great idea, I think. But I think one of the things we learned is that if at all possible with your audience, I think it's a good idea to incorporate async into your course. I was really hesitant before whether I should introduce it because of the loads of concept that it involves. But it really shows why concepts are the way they are in Rust. So it really makes all things come together a bit. And this is great about this topic. Also, I think we could have compared async a bit more with other implementations and other paradigms as well. And one thing you shouldn't do when you introduce async Rust to students is, well, underestimate the complexity. We based this module on the async Rust book, and I really would recommend reading this book because it really goes into, well, futures from the ground up and how executors work and all the fundamentals, and really unmagicalizes them, so to speak. And they learn a lot. And then there was module P, the final project. And the goal of the final project was to internalize concept that we had learned, and most of all, have fun with Rust. So the idea was that the students were going to write a proposal of like 1.5 pages, small one, with some broad ideas and dependencies they were going to pull in, maybe a bit of a diagram on the parts of the system they were going to create. And then they had time to create their application for a couple of weeks. And at the end, we did a demo, and they wrote a short report reflecting on what they did and why. So, and this was really the focus, so reflecting on design and dependencies and features used. So it's great to have them reflect on what actually they have been doing, and I think they did pretty well. So here's some example projects. And these projects are from people that didn't know Rust before this course. And so I think this is really impressive. One of the projects is an image manipulation API based on XM. It's a REST API to which you can upload images, and you can do all kinds of transformations. You can even do face recognition on them. It draws boxes around faces using the ONNX neural inference network. So that was really awesome. Another one was on linked lists. If you've got Rust experience, you know doubly linked lists are, well, tricky. They're famously tricky. So these students, they were having a data structures course in the next semester, and they wanted to, well, combine their Rust knowledge with the data structures course. And so they said, we're going to implement all kinds of data structures, and one of those was linked lists. So we told them, yeah, just try to get started with writing doubly linked lists, and then report on how that went. And it was pretty cool. Each week they were complaining, well, not complaining, like funnily complaining some about how hard everything is, and how convoluted it has to be to actually work ergonomically and performantly. So they implemented various linked lists, various kinds, and they based their works on the book, the Learning Rust with Entirely Too Many Linked Lists, which is a great read, I think. And there were loads of hard things going on with references. They did stuff with, well, raw pointers as well. They did stuff with heap allocation. And what I think was nice is that they did a lot of benchmarks using Criterion against other data structures and against the stud implementation of linked lists. And I was really impressed by this project. So overall, I think the projects were very, very impressive, and therefore the pass rate was pretty high, and we had loads of fun. I was truly impressed by the students of Bratislava. So yeah, I would say it's a success. So let me tell you a bit about the future of Rust 101. So we currently have a tailor-made course, and how do we actually make this a living project that people can reuse? So the first step is making it modular. And we want to make it from a tailor-made course to a structured set of topics. So that means dividing up the modules up into topics, and for each topic specify the dependencies and goals. So if you have a certain topic and you want to assume that other knowledge is there, so you want to require some knowledge, then you should be able to do so. You should be able to relate exercises to topics. So in the course we just had exercises that went with modules, but now we should relate them to specific topics as well, so you can swap them out, so to speak. We wanted to define more tracks, so we now had a track for intermediate C++ programmers, but it would be cool to add tracks on, for instance, embedded. I would love that. It would be cool to add tracks for beginners, beginning programmers, if at all possible. And also, we'd need to create more modules. And so this part is done, I would say, currently. And then the next step is to enable reuse. So then we have a set of topics, and we want to make it into a basis for more courses. And so now we have to restructure our project into a real open source code base, so other people can actually understand what we're doing and how we've structured it. And we want people to easily define their own courses. So my idea with this is that you have some kind of definition file, a TOML file, for instance, and that you can just list which modules you want in your course, and then you run a tool, generate all the content, and then it's there. I think that would be great. Maybe create a website for it even. And also, this would allow courses to be created not just for universities, but for workshops or crash courses or what have you. I would also like to add more guides on usage, on contribution, and generally help people out get started with this material. And well, this is currently in progress. And then once that's done, we want to make it a real resource. So then we have modularized this content, and then we have all the guides available, but then it needs to become a proper open source concept. And well, Rust 1.1 is a success if it's contributed to by many people, like teachers, of course, but also students. Would be great if students were to add their own material. Developers, other Rust users, everyone that wants to improve Rust education should be able to do so with Rust 1.1. And this is where you come in. So how can you help? So first, a bit of a disclaimer. It's a bit early days, as I'm not done with the reuse part just yet. It's almost there. But still, some things that you can do is improve existing content. Some people have been doing spell checking on our content, which I think is great, but also some diagrams could maybe become more clear, or exercises could be improved. So if you like to do that, just go ahead, open a PR. Also, we'd love to get more ideas on this project. So I'm just an engineer. I don't know a lot about teaching. I know that I like teaching, but I also want to learn from experienced people and opinionated people as well. So share your ideas. You could add not yet covered topics, or you could make the material suitable for other audiences, like, well, for instance, new programmers or programmers without systems background, maybe Python programmers, or even non-Western education. You could design new tracks, And generally, just let us know what you'd need for it to be usable for you. Yeah, and if you like to do so, please open an issue, share your ideas, and let's discuss. And I think one of the main other things that you can do is tell your friends. So if you're interested in learning Rust at your university, tell your teachers about this project, and hopefully they will be able to contribute or use this project. That would be really great. So then, that's the end of my talk. Thanks.